Hi friends, welcome to another series, the hypothesis testing. Hypothesis testing is one of the important activities in statistical analysis. When you can't decide what to do from the data, then we need to take help of a probabilistic approach. And while dealing with a probabilistic approach, the hypothesis testing is one of the important activities that will help us in proceeding further. Hypothesis testing is the process used to evaluate the strength of evidence from the sample and provides a framework for making determination related to the product population. This hypothesis testing provides a method for understanding how reliably one can extrapolate observed findings in a sample under study to the larger population. So when we are doing some study, we do experimentation, and during experimentation the observations are collected and they are finite in number, but when we need to analyze, the available samples may not be sufficient or may not give the overall picture of the scenario. In such cases, we need to extrapolate the information from the available findings and to make it work for a larger population. So when the data is from a larger population, we collect some samples out of it, and on the samples we work on this. And while working on this, it's very much convenient to proceed through this hypothesis testing. Hypothesis testing has been likened to a criminal trial in which a jury must use evidence to decide which of the two possible truths, whether the person is innocent or guilty. If he is innocent, we can call it H0. If it is guilty, we can call it HA. Why they are, we'll see in our coming session. Here, the jury is instructed to assume that the defendant is innocent unless proven guilty. So, sufficient evidences are required to prove that a person is guilty. If such thing is not available, then he will be assumed to be innocent. But of course, proving that not guilty does not mean that a person is innocent. It only says that sufficient evidence to prove guilty was not available. So on the ground of confusion, it's left as not guilty and not as a innocent. The same way, if you do not reject the H0, it does not mean that it is true. What is H0? What is HA? We see that. Now, definition of hypothesis. It's a supposition or a proposed explanation made on the basis of limited evidence as a starting point for further investigation. So when you need to make investigation, we have to start somewhere. When you are beginning some investigation, we have limited evidence available with us. Using these limited evidences, we need to go further, dig further, and collect more and more evidences and propose the things. Null hypothesis is a proposition made as a basis for reasoning without any assumption of its truth. So when the truth is not clearly known, then we propose on basis of reasoning, and that's what we call hypothesis. Hypothesis, in other way, can be defined as a testable statement about the relationship between two or more variables, or a proposed explanation for some observed phenomena. Can also be explained as a statement of expectation or prediction that will be tested by research. So this all hypothesis testing, everything is related with research. So has got a very important requirement in research. So why do you require this hypothesis testing? Why it is so important? Here, a hypothesis enables researchers not only to discover a relationship between variables, but also to predict a relationship based on theoretical guidelines and or empirical evidences. Yeah, that will help us to put the lines between the variables and create a relationship, and then through this relationship we can predict the other things through extrapolation. Hypothesis testing allows researchers to determine whether the data from the sample is statistically significant or not. That's another version of statistical test. Hypothesis testing is when the researcher collects data, then will this data useful for our work or not, we need to decide. So is the data is useful for our experiment or not? That has to be decided before using it, because sometimes the data is very much useful for our experiment. Sometimes it makes no sense in our experiments, or some other time it is giving a negative effect to our experimentation. So we need to make sure whether the data we are using are statistically useful or not. Then hypothesis is an approximate explanation that relates to the set of facts that can be tested by certain further investigations. And here we have two important things. One is a null hypothesis and other is a alternative hypothesis. There are four sources of hypothesis: previous study, personal experience, thinking, and imagination. Details follow soon. The null hypothesis of a test always predicts no effect or no relation between the variables, while alternative hypothesis states that a research prediction of an effect or relationship. So when we are comparing two variables and we try to see whether they are related or not, then the null hypothesis say that they are not related, whereas the alternative hypothesis say that they are related, or the other way. And as assumed in the criminal example, the null hypothesis is assumed to be valid unless until it is disproved through evidences. Like a person is assumed to be innocent unless proved guilty. In any hypothesis testing, the null hypothesis is assumed to be valid unless until it is disproved through proper evidences and all. So when it is disproved, then alternative hypothesis is true. So usually what we do is we take a random sample from the population, and if the sample data are consistent with the null hypothesis, then we do not reject the null hypothesis. If the sample data are inconsistent with the null hypothesis, then we reject the null hypothesis and conclude that alternative hypothesis is true. The example is given the test scores of two random samples, one of men and one of women. Does one group differ from the other? Is the experiment we are conducting. And the possible null hypothesis is that the mean of male score is same as the mean of female score. So that's a null hypothesis. So we assume that the mean of the two male and female scores are equal. And the alternative hypothesis may be in many ways are unequal, or male mean is greater than female mean, or female mean is greater than male mean. So depending on the problem we are solving. So there are three types of hypothesis: simple hypothesis, complex hypothesis, directional hypothesis. Simple hypothesis is one where the whole population distribution is used completely, and in this case the sampling distribution is static. Under composite hypothesis, the whole population distribution is not used. So here the hypothesis is specifying that the distribution is normal, but we don't know the variance, we know the mean. So incomplete information is available, then we are doing composite hypothesis. When complete information is known, like we know that the distribution is normal and mean is also known, variance also known, then we can think of simple hypothesis. Other way we can say it's exact hypothesis. That means you are just trying to say that it is exactly equal to something. That's a point hypothesis. So the null hypothesis may say that the mean is equal to 100. Then alternative hypothesis may be mean not equal to 100. Then another way is inexact hypothesis. Their parameter range or interval is specified, like null hypothesis may say that the mean is less than or equal to 100. Then alternative hypothesis will be mean will be greater than 100. Or the null hypothesis may be the mean is within the interval 95 to 105, and the alternative hypothesis may say that it is out of this range. Then when you're talking of incomplete thing, there is one-tailed hypothesis. That's only one side of the thing. Above or equal to certain value, below or equal to certain value are considered. And one-tailed hypothesis is said to have directionality. So either you are talking of left side or right side of the data. Null hypothesis. In statistics, it states that there is no difference between groups or no relation between variables. It is one of two mutually exclusive hypotheses about the population in a hypothesis test. So when the sample contains sufficient evidence, we can reject the null hypothesis and conclude that the effect is statistically significant. So the null hypothesis usually says that the data is having no statistical significance, but if we can reject it, if we can disprove through sufficient evidence, then we can say that the alternative hypothesis saying that the data is statistically significant. So null hypothesis, usually represented as H0, has no effect exist in the population. And alternative hypothesis, HA or H1 denoted, says that the effect exists in the populations. We are talking about some effect. Then we are looking at the data, and we say that if there is no such effect exist in the data, then it is null hypothesis. If there is some effect is there, then we say there is alternative hypothesis. So unless until disproved, the null hypothesis is true. So acceptance or rejection of null hypothesis depends on the p-value. A p-value is a crucial part of the statistical results because it quantifies how strongly the sample data contradict the null hypothesis. Yes, we need some numerical way. All now we were talking everything qualitatively, and when it comes to exact working, we need quantitative. So something quantifying is required, and that is done through p-value. So p-value is some statistical process from where we use to contradict the null hypothesis. So the p-value, if it is greater than some value, then we can't reject the null hypothesis. When the p-value is less than some known value, some decided value, then we can reject the null hypothesis. So rejecting null hypothesis definitely does not mean that null hypothesis is wrong. Yeah, we can reject looking at the evidences. So rejecting null hypothesis, when the p-value is less than or equal to the significance level, we can reject it. And when the p-value is greater than the significance level, then we fail to reject null hypothesis. We are saying that we are failing to reject null hypothesis. Doesn't mean that we are accepting null hypothesis. So these are confusing terms. Yes, because perfectly we can't say, surely we can't say that this is right or this is wrong. So we can say this may be right, this may be wrong. Now in probabilistic language we may try to say that this is right, this is wrong. No, this may be right, this may be wrong. How strongly you claim that it is right, how strongly you disclaim that it is right. Yeah, all these are the issues which are taken care by the p-value. And what p-value is, yeah, with examples, let us see what the p-value in our next session. So keep watching. Thank you.